Hi everyone, welcome to Math with me. So today we are going to start this new chapter called as Introduction to Trigonometry. And I know most of you guys are worried about this chapter, but do not be because I am here to help you understand all the concepts clearly by the end of this video. So before getting started into this chapter, let me just give you a small recap of Pythagoras theorem, which we had already learned in previous classes. Pythagoras theorem is nothing but finding the unknown side of the given triangle. So for this given triangle right here with angles A, B, and C, which is right angle at B, we can say that the square of the sum of lengths of two sides of the triangle is equal to the square of the length of the hypotenuse, which is AC in this case, and it is also called as the longest side in a triangle. So let us just take a small example to find out the unknown side of the given triangle, where the values of AB is given as 3 and BC as 4. So on applying Pythagoras theorem and substituting the values of AB and BC in the equation, we get AC square is equal to 9 plus 16, where AC becomes root 25, which is nothing but 5. So moving forward with that, let us just begin with our first concept of introduction to trigonometry, which is nothing but naming the sides of the triangle. Just like how we had named the longest side of the triangle as hypotenuse, in the same way, this concept we will be learning how to name the remaining sides of the triangle, which is nothing but AB and BC. So before we begin with this, we need to know that we cannot name the sides of the triangle from 90 degrees angle. So which in turn means that we can only name the sides of the triangle from angle A or from angle C with respect to this triangle. So keeping this rule in our mind, let us just consider naming the sides of the triangle from angle C. The side AB, which is exactly in front of angle C, is called as the opposite side of the triangle. And the side BC, which is exactly next to angle C, is called as the adjacent side of the triangle, which we already know about side AC, which is called as the hypotenuse. It is the longest side of the triangle. With this, we know how to name the sides of the triangle from angle C. But will the name of the sides of the triangle be the same from angle A as well? We will have to look up on that. So let's just consider angle A. The side BC becomes the opposite side this time, as it is exactly in front of angle A, and the side AB becomes the adjacent side, as it is next to angle A. And we already know the side AC remains unchanged. It's called as hypotenuse of the triangle. With this, we have learned how to name the sides of the triangle from angles A and C. So now we need to understand what exactly are trigonometric ratios. They are nothing but fractions of two side lengths of the triangle, and for these fixed fractions, we have given them a constant name called sine, cos, tan, etc. With this, let us begin with our first trigonometric ratio, which is sine, where sine is nothing but opposite by hypotenuse. We can write this in two different ways because the opposite side of the triangle differs from which angles we are referring to. From angle C, we can write it as AB by AC, as AB becomes the opposite side with respect to angle C. Similarly, from angle A, we can write it as BC by AC. Moving on to the second trigonometric ratio, that is cosecant, which is given by hypotenuse by opposite, which is the reason why we can write it as 1 by sine. From angle C, we get AC by AB, where AB is the opposite side with respect to angle C. Similarly, from angle A, we get AC by BC. And our third trigonometric ratio is going to be cos, where cos is given by adjacent by hypotenuse. So from angle C, it becomes BC by AC, as BC is the adjacent side with respect to angle C. Similarly, from angle A, it becomes AB by AC. Moving on to the fourth trigonometric ratio, that is secant, which is given by hypotenuse by adjacent. So we can also represent it as 1 by cos. From angle C, it is represented by AC by BC, where BC is the adjacent side with respect to angle C. Similarly, from angle A, it is represented by AC by AB. Moving on to our fifth trigonometric ratio, that is tan, which is given by opposite by adjacent. From angle C, we can represent it as AB by BC, where AB is the opposite side and BC is the adjacent side with respect to angle C. Similarly, from angle A, we can represent it as BC by AB. And our last trigonometric ratio is cot, which is given by adjacent by opposite. That is the reason why we can represent it as 1 by tan. From angle C, it is represented as BC by AB, where AB is the opposite side and BC is the adjacent side with respect to angle C. Similarly, from angle A, we can represent it as AB by BC. Let us now look into an example to understand the concepts clearly. If sine A is equal to 3 by 4, calculate cos A and tan A. Let us first draw a triangle with angles A, B, and C. And as we already know that sine A is given by opposite by hypotenuse, that is BC by AB. On comparing the values of sine A is equal to 3 by 4 with BC by AB, we get the values of BC as 3 and AB as 4. But to calculate the values of cos A and tan A, we must know the length of adjacent side of the triangle. So on applying Pythagoras theorem and substituting the values of AB and BC in the equation, we get AC squared is equal to 16 minus 9, which on further simplification we get AC as root 7. Now that we have found out the value of the adjacent side, we can substitute the value in the equation of cos and tan that we previously learned, where cos A is adjacent by hypotenuse, that is root 7 by 4, and tan A is opposite by adjacent, that is 3 by root 7. Moving on to the second question, that is 25 cos A is equal to 16. Calculate sin A. You guys will be taking up this question, and I want you guys to comment down the answer below. So with this, we are done with more than half of the chapter, and we will be learning the remaining concepts in the upcoming video. You do not want to miss out my upcoming videos, so please do subscribe to my channel. Thank you for choosing Math with me. Have a great day.